Hi, in this lesson, I want to explore one of the main features of the Martian surface. What you're looking at here uh, is a map of the elevation or the height of the surface on Mars. The bluer colours are the lower areas of the surface. The uh, red and white colours shows the higher areas. So, for example, we can fairly easily pick out the enormous volcano of Olympus Mons on the left-hand side of this map. But it's not the volcanoes I want to look at in this lesson. It's one of the most spectacular features that we find on Mars, a place called the Valles Marineris. Now, this is a feature that we find around sort of the Martian equator. It's an enormous canyon. Its scale is quite staggering. It's 4,000 kilometres long. It's about 200 kilometres wide and up to 7 kilometres deep. Just to put that in some type of perspective, on Earth we have the Grand Canyon in America. The Grand Canyon's 446 kilometres long, 29 kilometres wide, and up to 1.9 kilometres deep. The Valles Marineris is an order of magnitude bigger than anything we have on Earth. So, we need to have a look at the geology behind this. Why we have a feature of this scale on the Martian surface. And to do this, we're working on page 19 of your Theme 2 booklet. What I want you to do is I want you to apply what we've learned throughout the whole of this topic. How we can look at an image of the surface of another planet like Mars and apply our understanding of geology to actually work out how this formed. You have this image. What I'd like you to do is I'd like you to annotate this image. What can we actually work out about the Martian surface from what you can see? Label up the features you can identify. Can we explain then how each of these formed and what evidence we use for that? Think carefully about it, see what you can come up with. So now it's time to press pause and have a go at that activity. See if you can also recognise some of the other features around the Valles Marineris for the digging deeper activity. Okay, let's see what we've come up with. These are some of the key features I've identified in terms of how this feature formed. The main feature running through the middle here is the canyon. This long, deep feature, probably formed by some form of erosion. You'll see on both sides of the canyon, we've got these V-shaped side canyons. This is where water must be flowing down the side of the canyon, eroding out these valleys. We can find the same features here on Earth. Places like Death Valley, for example, will see features very similar to this. Have a look perhaps on Google Earth for Death Valley. See if you can recognise some similar features. We've got some features here that suggest some plate movement. If you look, especially just to the north, near the top of this image, we've got a series of very long, hundreds of kilometres long, very straight, parallel cracks. This perhaps suggests that there's been some plate movement, that the crust here is being pulled apart a little bit. We're getting these cracks. Notice as well how the canyon is parallel to those cracks. It can't be a coincidence that that's occurred. Straight lines are very, very unusual in geology. Where we find a straight line, there's got to be some geological explanation for it. They don't happen by accident. Also, there's a ridge down in the bottom of the canyon there. Perhaps again related to plate tectonic movement. The way that the rocks have broken up here. Again, look at that ridge. See how it's parallel to all these other features. So clearly, this canyon has been formed perhaps as a weakness created by plate movement that's then been widened out by erosion. But if we think about the scale of this, think about the amount of water that must be in there. It must be enormous. We can also see some other features. We see craters. Now, this isn't related to the formation of the canyon, but clearly this area has been bombarded. Now, like we saw on the moon, there's a larger crater here with some evidence of landslides around the rim, perhaps suggesting it's quite an old crater. It suggests this area around the Valles Marineris is an old part of the crust. There are newer craters as well, smaller ones, again like we saw on the moon, that have these sharper edges. What I think is interesting though, is if you look at how many of these craters there are around the top surface of the canyon, and then we look at the bottom surface of the canyon, and we don't see any. Now, does this tell us that this canyon must have formed a long time after the meteorite bombardment? Possibly. Does it perhaps suggest that what we see in the bottom of the canyon there, that very smooth surface, is actually formed by deposition of sediments, where erosion of rocks from the area around the canyon has swept that rock material into the bottom of the canyon and left it there as this smooth surface, perhaps filling up any craters that may have been there. What does that tell us about how long liquid water existed on the surface of Mars? Are those sediments must be younger than the rocks they eroded from, but how much younger? I think this is it's a fascinating area for us to look at, and we can interpret a huge amount of the history of this area just by making these careful observations. So, as we watch the sunset of the Valles Marineris, let's think about what we've done. We've made a series of careful observations about the surface. From that, we can then start to draw more and more interpretation from it. But we do need to think carefully. What are the mechanisms of formation of these features? What order can we put them in? Okay, it's that thinking, those problem-solving skills we apply to make us good geologists. Next time, we're going to have a look at how we actually go about exploring the detailed geology of Mars. I'll see you then.